Microservices DP, March 31st. Done. Yes, boss. So today we'll try to understand what is microservice architecture. Microservice architecture. Yeah, video cannot be given, guys. For next 2-3 days, video cannot be given. Please adjust. What is microservice architecture? Some maintenance work is going on in my home. Right, boss. Microservices DP, boss. Microservices DP. Microservices design patterns. Yeah. Yeah, it is for those students who are already having design patterns knowledge, who are already know what is microservices. Okay. What is microservice architecture, guys? Yeah, the people who just know Servlet JSP, Tata, bye-bye for them. If you sit also, it's a waste. Okay, if you sit also, it's waste. But if you want to continue, you can continue. Not a problem. Yeah, microservice architecture says, okay, develop every service as separate project. Separate project. Nothing but executable application. Separate project. Executable application. Nothing but REST application. REST application. REST application. So that we can activate or deactivate. Okay, activate or deactivate services as per our need. As per our need. As per our need. Okay, guys. Now tell me here. Flipkart project. Flipkart project using microservice architecture, guys. Flipkart project using microservice architecture. Yeah, tell me. Right, guys. This is login service. Login and registration service. Login and registration service. Login and registration service. This is MS1. This is MS1. Okay, as REST application. As REST application. Next was shopping service, guys. Shopping service. MS2. As REST application. As REST application. Nice, boss. As REST application. Next, as a REST application. Now, what is the next one, guys? Payment or billing service. Billing service. MS3. Array MS means microservice 3 ra babu. As a REST application. As a REST application. As a REST application. Okay. Right. Now listen, guys. All these services will be talking with each other. Will be interacting with each other. Will be talking with each other. Will be interacting with each other. Understanding my statement, guys? Will be talking with each other. Will be interacting with each other, guys. Super, guys. Yes, boss. Right. What is the advantage? Now listen. Since each service is developed as a separate REST application. Okay, REST application. We can take more instances of okay, busy service and less instances, less number of copies, guys. Instance means copy of the application. Less instance for okay, less instance for okay, rarely used or oftenly used services. Oftenly used services. What, guys? Oftenly used services. Are you comfortable, guys? Are you comfortable, guys? Come on. Are you understanding my statement, guys? Okay. Okay. Instance means instance of the service or application means a running copy of the application or service. A running copy of the application or service, guys. Comfortable, convinced, guys? A running copy of the application or service. Okay. Example. Okay. Since shopping service will have more traffic and more requests from more users, we will take more instances for it. Okay, for it. And only what is that? 30% of the users who do shopping go for billing or payment. Go for billing. Actually, 50% people will go for billing, guys. Okay, billing. So we can take less number of instances for billing service. Come on, guys. Okay. Only 20% users generally go for payment. So we can take more less number of instances, for what, guys? More less number of instances for payment service as needed. Payment service as needed. I hope you understood, bots. Microservice design patterns are given. Design patterns are given by keeping to HU, okay, given to HU, the following, benefits from the microservice architecture based projects. Microservice architecture based projects, guys. Are you listening my statement, guys? Microservice architecture based projects, guys. Yeah, number one, scalability, guys. By applying microservice design pattern. Okay. Right. Microservice. By solving the common problems. Yeah, we would like to achieve scalability, guys. Okay. We would like to get flexibility, guys. Ability to increase or decrease is called scalability. Flexibility. Next. Okay. We want to get independentness and autonomous behavior. Independent. See, guys. Okay. Independent and autonomous behavior. University is called autonomous university if they are directly conducting exam, correcting the paper, releasing the mark sheets. Esa no na. Independent and autonomous. Independent and autonomous. Next, what is next one? Resiliency. Resiliency means if any problem comes, guys, if any problem comes, that should be displayed properly without affecting other things. Guys. That is called resiliency. Okay. Next. Okay. Continuous integration and delivery. Okay, guys. Continuous integration and delivery, boss. Okay, continuous integration and delivery. So these are the things which we would like to achieve, guys. What is this, guys? Scalability. Ability to increase or decrease. Ability to increase or decrease. What, guys? Number of instances. What, guys? Number of instances. Mr. Sairam, availability consistency is there as part of what? Scalability itself, Rababu. Right, guys. Because scalability is there for availability and consistency only. Now, what's flexibility? Ability to use our choice, one or more services together. One or more services together. Next. Ability to use each service Okay, each service in different projects. Yeah, in different projects. It's something like this, guys. You are an employee of an organization, but in your free time, you have given permission to work for. In your free time, you have given permission to extend your services for other organizations. To extend your services for other organizations. Are you getting my point, guys? Next, resiliency. Resiliency. Taking care of failovers. Taking care of failovers. Taking care of failovers. What do you mean by taking care of failovers, guys? Taking care of failovers. What do you mean by failovers? Taking care of failovers. One server is down, one application is down, failovers. That means if one service is down, going to other service. Going to other service. Next, continuous integration and delivery. Ability to have modifications and releases continuously. Release modifications and releases continuously. Releases continuously, guys. Are you understanding my statement, guys? So these are the these are the various things that I would like to concentrate, guys. Okay. So there are some important design patterns, guys, which I would like to cover one by one. Yeah, listen, for the people who already know, design microservices, guys. Okay, conceptually you'll be understanding, guys. Programmatically also you'll understand. Remaining people, try to understand conceptually. Programmatically you may get problems. Okay, boss. Now tell me here. To provide above benefits. Wherever possibility is there, we will see programmatic knowledge also. Don't worry. To provide above benefits, guys. To provide above benefits. Okay. Okay. We can use the following microservice design patterns. We can use the following microservice design patterns, guys. Okay. Design pattern, microservice architecture design pattern. In shortcut, they are called microservice design pattern, guys. Architecture design pattern. Number one, database per microservice. Every microservice should have a separate database. It does not mean all of them should use. Each of them should use one. You should use Oracle. One should use MySQL. Not like this. Every database, every microservice should have at least its own logical database. Should have its own logical database. Understanding my point? If possible, multiple instances of Oracle, multiple installations of Oracle. MS1, Oracle installation 1, MS2, Oracle installation 2, MS3, Oracle installation 3, or at least a separate logical database in each. This one. Database per microservice. That is one pattern, guys. That is one pattern. Event sourcing. Okay. CQRS. Next, Saga. Okay, Saga. API gateway. API gateway. Next, circuit breaker. Circuit breaker. Next, externalized configuration. What is that? Externalized configuration. Okay, actually, some of them we already studied as part of microservices. Okay, what is that? Consumer driven contract tracing. Consumer driven contract tracing. Okay, consumer driven contract tracing. These are quite popularly used design patterns, guys. Okay, popularly used design pattern that are there in microservices environment. So shall we take one by one? Yeah, abbreviations, everything I will give when I launch each one. Are solid is the principles, ra babu. Solid is not actually okay. Solid is not a design pattern. Solid are the principles. Principles. If possible, I'll talk about solid principles. It's not like that. Okay. But it won't come under what? Design pattern. Solid principles. A microservice architecture application should satisfy solid principles. Understanding my statement? Solid is not a design pattern as per my knowledge. Right. Shall we get into the discussions, guys? Yeah, we'll talk about this. We'll talk about solid principles also. These 7 or 8 plus solid principles I will talk. Right. Definitely I will talk about this. Don't worry. Don't worry about that. Yeah. Shall we take a database per microservice, guys? Database per microservice, guys. Everyone, focus. Normal project, nothing but monolithic, guys. Monolithic. You know that. Those who studied microservice with me. Monolithic or microservice. Okay. There are two ways. There are two ways to configure the database software. Okay. Number A. There are two ways to configure the database software. Number one, yeah. Database per service. Next, shared database. Next one is what? Shared database. Each MS will use separate DB software or its instance. Okay. All MS. Okay. All MS together use same database software or its instance. Same database software or its instance, guys. Okay, here problem is shared database. What is the problem, guys? Shared database. Basically, problem with is what? Shared database, guys. Okay, shared database. Sir, shared database only good na, sir. Shared database only good na. Okay, actually the usage of shared database is a anti-pattern, boss. Okay. Listen guys, why? When all microservices are using single database, they're losing their scalability, na? See guys, so many microservices are so much data added. When data added, database size cannot be grown, na boss. Come on, come on. Database size can be grown, na? No. And we will be losing robustness. We will be losing independent feature. Come on, guys. Every microservice can be independent of its own. No, because all microservices using same database. Database down. All microservices are down, right? We will be losing that flexibility feature. We'll be losing that independent behavior feature. We'll be losing that scalability feature. Are you understanding my statement, guys? In monolithic, it's good, guys. But when you run every service as a separate application, every service should have its own database or not. Okay. Are you understanding my statement, guys? Okay. That here, all services, all services, all services together use same database software or database instance. Same database software or database instance. Okay. Right. Actually, microservices using shared database is anti-pattern. What pattern, guys? Anti-pattern. Anti-pattern. Okay, here note. Best solutions for the problem is called, guys. Best solution for the problem. Solution for the problem is called design pattern. Whereas worst solution for the problem is called what pattern, guys? Anti-pattern. Worst solution for the problem is anti-pattern. Okay. So how does it looks, guys? How does it looks? Yes, here is my MS1, MS2, MS3, MS4, MS5. Some microservices, ra babu. All are interconnected. MS1, MS2, MS3, MS4, MS5. Total, how many microservices are there, guys? Right. 5 microservices are there. Are you listening my statement, guys? Total, how many microservices are there? Okay. This is shared database, which is basically anti-pattern. Anti-pattern means worst solution for the problem. Okay. Yeah. Now listen. All of them are interconnected with what? Single database software. Here is my database software, guys. Right. Here is my database software. Here is my database software. Nice. Okay. Yeah. Listen, this is the problem, guys. What is the problem? All right. Okay. Cons. First, I will talk cons. Problems. Cons means problem. If all microservices together using what? Same database software, what is the problem? What is the problem? Microservices become non-scalable. Got it, guys? How can you say they become non-scalable, guys? Array. It's data come. Okay, as data increases, you have to increase the database size. Array, database is installed in your computer, will definitely have one upper limit or not? Will have one or other upper limit or not? Come on. Okay, you have to increase what? RAM size. You have to increase hard disk size. You have to choose bigger database softwares. Come on. Right? As data is increasing, in multiple MS. Okay. In multiple microservices. As data is increasing in multiple microservices. Okay. We need to change the database software, or we need to increase RAM size, or RAM size and HDD size in the computer, which is a challenging issue now, boss. Challenging issue or not? Okay, guys. Microservices. Okay. Lose their independent or autonomous behavior. Independent or autonomous behavior. What do you say, guys? Microservices lose their independent or autonomous behavior. What is that, my dear? Independent or autonomous behavior, guys. Right, guys? Independent or autonomous behavior. Autonomous behavior means what, guys? They are dependent with each database. Na? They don't have their own database, right? Okay. Next. Microservices lose their portability. Understanding my statement? I want to move microservice to some other environment. Without database, can I move? No. Suppose every microservice is having its own database. What happens, guys? What happens? Array, I can move microservice and its database both together. But now one microservice in X environment, another microservice in Y environment. Both want to use same database. Can I move two different microservices in different environments, guys? No, right, boss? Right, guys. All microservices are forced to execute in same platform and environment. Same platform and environment. What do you say, guys? Are you finding all these are the problems? Are you finding all these are the problems, guys? Right, guys. Next. Pros, guys. Are there any advantages? Are there any advantages, guys? Now tell me. Transaction management becomes easy. Array, all are putting data in same database software now. Was transaction become easy. Transaction management becomes easy. Okay, local transaction management is sufficient. Local transaction management is sufficient. Okay, sufficient. Sufficient, guys. Okay, guys. Final note, guys. Okay. In monolithic application, monolith means normal application, guys. In one project, all modules will be there together, right? In monolithic, I think I need not to tell what is monolithic application. What is this? All services as modules in single project. All services as modules as single application or project, guys. In monolithic application, what application, guys? In monolithic application, all services as modules in single project or application. Okay. Prefer this kind of single or shared database software. But in microservices preferred, what is that? Database per service. Database per service. Right, guys. Solution. What is that? Database per service. Database per service, guys. This is a design pattern. This is called design pattern, guys. This is solution, guys. Database per service, this is called design pattern. Literally, solidly, this is called design pattern, boss. Shall we get into the discussions, guys? Yes. Tell me. What is design pattern, guys? Every service, every microservice will use separate database software or instance. Separate database software or instance. Right, boss? Try to observe this. How does it looks? MS1, it's MS2, MS3, MS4. Okay, fine. MS4, MS only I will take. What is there in that? MS1, MS2, MS3. Lastly, what is that? MS4. Okay. It is having its own database. Sir, what about it is having its own database, guys? It is having its own database software. Nice, boss. Copy this, done this, done this. Yes, everything is having its own database software now, boss. Right. Okay, all are interconnected. No doubt, all are interconnected, guys. MS communication will have. Sir, if this microservice needs this data, when it talks to this microservice, it collects the data and gives as a JSON data, right? It collects the data and gives as a JSON data. One microservice can pass data to another microservice or not? Definitely can pass, boss. Definitely can pass. No second thought in that. Comfortable, guys? Every microservice is having its own database. Okay, guys. Yes, boss. Right? Try to observe the pros and cons of this. Pros, positives, guys. Scalability is more. Each service database software can be made scalable. Can be made scalable. What do you say, guys? Can be made scalable. Definitely can be made scalable. What is the next one? Okay. No, sharing is not good. Scalable means increasing. Next, Every microservice, every service data, array service means microservice. Data, domain data, domain data is encapsulated. Is encapsulated. Encapsulated. That means one service means MS. Here service means MS. One microservice cannot get other microservice data. Indirectly data protection is coming or na boss? Other MS data, other MS, other service, nothing but MS data. Clear, my dear? Got the clarity, guys? Okay. Understanding service, enhancement of service becomes easy. Enhancement of service becomes easy. Because every service is having own database and suitable for okay, new developers of microservice project. Services become independent and autonomous. Independent and autonomous. Come on. Okay. Some services can use SQL DBs and some other services can use NoSQL DBs as needed based on the format of the data. I hope you are understanding my statement, guys. Come on, guys. Try to visualize. Everything is having its own MS, right? Next, different MS can be placed in different platforms. Different platform because they have their own database. They have their own DBs, guys. Tell me, guys, cons. We definitely need distributed transaction management support. Transaction management support that runs on 2PC, two-phase commit protocol. That runs on two-phase commit protocol. Are you understanding my statement, guys? That runs on 2PC, two-phase commit protocol. I hope you are understanding my statement, guys. Right. Okay, now onwards, every microservice should have a separate logical DB or separate instance of database or separate database software. Understanding my statement? Conclusion. Conclusion. In microservice architecture, every service, in fact, MS, should have separate database software or logical DB or database instance or a copy of database software, guys, or okay, what is that? Schema having all tables. Yeah, this is the nice thought, guys. Let them use, all the people use same database. At least try to have separate logical DBs. Let all the people use same database software. At least try to have separate copies. Okay. Or it's better to have a separate database software. MS1 Oracle, MS2 MySQL, or MS1 separate installation of Oracle, MS2 separate installation of MySQL. Got the point there or not there? If worst case, at least every separate user, schema means user na boss. Schema means user, right? At least you should everything should have a separate user. At least every MS should have a separate user, guys. The best is separate database software. This is the first priority. This is the second priority. This is the third priority. This is the fourth priority. That's it, guys. This is the fourth priority. Convinced, my dears? Enjoyed by us? Okay, this is about what? A database instance means separate instance of Oracle. One more copy of Oracle. Oracle is installed once, but service is started twice. Microservice people, RESTful application developed once, but started twice, right? Each running is called one instance. Similarly, Oracle is installed once, but started twice. You know that is, you know that, you can feel it. Right, guys? JVMs. JDK is installed once. For every command prompt, separate copy of JVM will come, right? Browser is installed once, but every time when you launch browser window, one copy running or not? One copy of browser software is running or not? Come on. One copy of browser software is seriously, literally running or not? That's it, guys. That's it. Fine, boss. Thank you, guys. Tomorrow when we meet, we will take another one. LS. Just know in advantage list, some services can use SQL DBs. Some other services can use NoSQL DBs as needed based on the format of the data. Yes or no? Na. LS is, you are asking confirmation. Okay. Right. LS has got these questions, guys. Okay. LS has got his questions. Sir, in one interview, it was asked to me like that. Can we keep separate DB software? Yes. Can you keep one SQL, one NoSQL database software? Yes. Okay. We'll use Polyglot, sir, in that case. Polyglot, if it is the database software, you can use it, guys. It's possible. Thank you, guys. We'll meet tomorrow and we will go for next pattern. Thank you.